Hello everyone, my name is Mark. So when I'm not programming or doing other computery things, I'm usually like eating food or making food, or I guess trying to make food would be a more charitable description. So if you also like any of these things, then you should definitely come and speak to me afterwards and we can geek out over cheese or whatever. If you want to follow along the fun with my adventures in making bread, then you can follow me at these places on the internet. I also tweet about JavaScript occasionally, so fair warning. All right, so by a show of hands, who here is familiar with Yelp? Maybe you've left a review at some point. Good, that's good to see. So for those of you who aren't familiar, Yelp is this platform, it's a website, an app, and so on, where you can, if you need a plumber to come fix your bathroom, or maybe you just need somewhere to go eat after the conference, Yelp is the best place to go do that. So now everyone loves a good before and after shot. This is what we looked like back in 2004. And from our humble beginnings, this is what we look like today. We've moved on quite a bit since then, and so has the web. Now, historically, Yelp's infrastructure is mainly Python-based, so our templates are all written in this thing called Cheetah, which is a Python-based templating language. And on the front end, we've been through quite a few migrations over the years. So we started off with Prototype. One team was pretty invested in MooTools. And then more recently, jQuery and Clojure, compiler, and library. And then over this past year, we go do it all over again. So we've just spent the past year migrating to React, and that's what I'm here today to tell you all about. So I wanted to share some numbers with you that kind of represent the scale with which we do things at Yelp. The one that stands out to me is the number of existing Cheetah templates that we have. And this equates to hundreds of thousands of lines of front-end code. So I think with all this, it's pretty fair to say that Yelp is not a simple CRUD app, as one might expect. So as I mentioned, Yelp has this mainly Python-based infrastructure. And so a shift to React implies this fairly big shift, both in terms of technical change and also a cultural change. There's quite a lot of buy-in that we need to get. Even though we know we want to migrate to React, we can't just dive right in and start changing stuff. There's all these questions that would need to be answered, and it's up to us as a web infra team to answer them from as an impartial perspective as possible. So the theme of this talk really is kind of walking you through what these questions were, how we went about figuring out the answers to these questions, and in doing so, how we were able to support this company shift to React. So the first question we need to answer is this worthwhile? Like, why do we want to do this in the first place? Obviously, being really excited about a new thing isn't enough. We need to figure out what are the tangible benefits of this new system. Does it justify the cost of migrating this? Does that, are we going to get good enough benefits from that? And spoiler alert, yes, but I'll highlight one or two of the things in this area that we identified that really gave us the confidence as a company to move forward and invest in this. So I'll briefly take you back in time and give you a tour of a classic Yelp web stack circa sometime early 2017. So as I said, we use a lot of Python, and our Python web server that we use for serving requests is this thing called Pyramid. And then below that, things kind of look fairly familiar, hopefully. So our templates are written in Cheetah, which I mentioned, and then we also have random bits of jQuery and CSS, and our markup are in these templates. And this serves us really well over the years, and as time goes on, as we add more code and things start getting more complicated, we start to notice some things that we could maybe do better at. Now, the first problem that we have is that unit testing a component is really hard. So to show you what I mean, here is an example of a component that we might want to test. So this is a template written in Cheetah. Don't worry about the syntax here yet. But know that this is code that gets executed inside of a Python environment, and it spits out markup when we do. So we have unit tests for this in Python, but what happens when we want to test the JavaScript that goes along with it? Okay, so you go, let's write some JavaScript tests in Karma or Mocha or Jest or whatever. So we write something like this, but since we can't really call Python inside of Node, or at least not terribly easily, we kind of have to copy what the generated output of the cheetah component would be and use that in the test and assert stuff about this like dummy fake markup. So this isn't really ideal, and it means that the best way we have to test a whole component is by spinning up all of our infrastructure and then hitting it with a headless browser like Headless Chrome or Selenium or something. So the next problem we have, and this one's been talked about quite a lot, but one component might be stored in 3 different places. So we have the JavaScript for it in a JavaScript file, the CSS somewhere else, and the markup stored somewhere else. And if you want to load one component onto the page, you have to do that 3 separate times with conditional logic going on maybe. And then you get this thing of where you have all these different files reaching into each other. The JavaScript expects the markup to look this way and have these certain classes, and the CSS expects the markup to use these classes. So what you end up with is this sort of manually defined, not very well expressed, brittle dependency tree. And if you change one thing, all these other things could break. So you have these very tightly coupled files. And this is quite hard to manage. So to show you a kind of real-world manifestation of this, I'll show you some examples. This is a shared hovercard component from our old Cheetah style guide component library. And you can see here, to load a hovercard onto the page, we load in some markup, we load in the JavaScript, we load in some CSS from somewhere else. Here's another example for a spinner component, and it's the same story. But what happens if we try this in React? So this is our React version of a spinner, and you can see there's just one thing to write. And that's great. Everything else figures its way onto the page intelligently and efficiently, and there's so much less room for things to go wrong. There's less mental overhead on the part of our developers. And so this is a pretty compelling reason in itself. And really, it's this argument of a better development experience in general that we found to be most appealing. Moving to a modern JavaScript ecosystem unlocks a lot of amazing tooling and solves some of these problems. So I'll just talk about one of these things on here, which is the generated documentation. The example that you saw 2 slides ago of the React version of our spinner, that was generated with this thing called React Style Guide dist, and it ties together inline comments inside of your React file, and it also ties together examples written in README files, and it creates this interactive developer playground. So, yeah, React Style Guide dist, really nifty, you should check it out. So is this worthwhile? Yeah, we think it is. Now the next question we might get asked is, can we migrate without significant disruption to our developers? So let's take a closer look at what a Cheetah template looks like. It's a superset of Python, so you can do logic inside of the template, if statements, while loops, and so on and so forth. You can see here that we're importing a template from somewhere else, and we're composing it on line 5 inside of div, and then that forms the complete template. Maybe this is a modal or whatever. So then a whole Yelp page might look something like this. We have a Cheetah partial composing other Cheetah partials, which call other Cheetah partials all the way down the tree, and at the bottom these leaf nodes might be small button components or other small bits of UI. So what we want to do is to go from something that looks like this to something that looks like this as quickly as possible. And we can't stop development across the whole company. We can't tell feature teams, hey, wait, a few months or whatever while we port everything to React. We need to be able to do this migration in place. We need to be able to swap individual nodes. Given that we don't want to be mutating React managed DOM from non-React code, we kind of have to start at the bottom and then gradually work our way up. So then the problem can be stated as thus. Given this template, we're calling a button component here from Cheetah. Imagine we've made a new React version of this button. How can we swap this call to the cheetah button on line 5 out for its new React counterpart? How are we going to call React from inside of cheetah? Okay, so let's assume that we have this magic function available to us inside of cheetah called render React components. Don't worry about how it works for now, but let's assume whenever we call it, it will execute the React component, get the markup, and put it inside of the template for us. Now, in the case of one-off partials, the migration strategy is easy. You just rip out the old cheetah partial, replace it with this, and you're good to go. In the case of shared components, like buttons, this is slightly harder. Now we have this kind of question, how do we and when do we use this new magic function? We have two ways of doing this, so suddenly we have this fork in the road. Now the first option is that we can go through all of the call sites and replace the call to cheetah with this call to React with this new magic function. And in this world, we've made the component again in React, and we're just calling that. And so then potentially we have two versions of our component floating about at any one time. We have the cheetah version and we have the React version. The second option, and notice there's no difference here, the second option is that we update the central definition of the button component itself to call render React component. So we're doing this one layer down, and that call to render React component becomes transparent to all consumers. We do it in one place and it gets magically updated everywhere. Now there's two interesting properties that option 2 has. The first is that there's thousands of call sites to a button component, so if we can do this in one place and not have to update it everywhere else, then that sounds pretty good. The second property is that since on these pages we already have markup, we already have the JavaScript and the CSS reaching into that markup, if we truly wanted this to be a drop-in replacement, we'd have to make sure that the markup that the React component spits out is exactly the same as the markup that the cheetah version spits out in order for the existing CSS and JavaScript to still work. So we need to make sure that the markup generated between the cheetah version and the React component is exactly the same. Now maybe that's actually quite good, because it means, well, we already have the CSS, we already have the JavaScript written for this component, so maybe we can just reuse that if it looks the same. So we go ahead and try and do this, and it turns out that actually option 2 is pretty bad. If we are going to constrict ourselves and make the React markup look the same as our old cheetah markup, then that means we're not writing idiomatic React code. It means that we have to enforce visual consistency with manual tests. And it also means that we don't get to use nice things like scope TSS classes. So yeah, we ended up going with option 1. We just remade all of our components in React. So we'll dig into how that magic render React component function works in a bit. So can we migrate without disruption? Well, maybe there's some investment needed. We need to do a whole bunch of manual migration work, but yeah, we at least have a path forward that we can swap out these nodes in place. We don't have to block anyone, so we can migrate without disruption. Now the next question we might get asked is, how will this impact performance? And this is a pretty broad term, so I'll split it up. And the first kind of performance we'll talk about is, are we going to degrade the quality of our first page load? Now let's say we just used React out of the box. When a user requests a page that's now entirely written in React from our server, it would look something like this. And notice there's something missing from here. There's a big gap where our content should be. And that's because obviously the React gets executed inside of the browser after the page is loaded. And that's fine for most users, but it's not so great for users who have JavaScript disabled, and it's not so great for SEO. Googlebot, Bingbot, and so on would just see this empty shell. And while some of them do execute JavaScript, we want to have slightly more control here. What we want to be able to do is send down something that looks like this. And then once this gets loaded inside of the browser, React can scan through the markup on the page, go, aha, you already rendered this component for me, so I'll just attach myself to that. I won't do the work myself, and then that's slightly more efficient. And that's client-side hydration. So we want to be able to do this from our side of things. We want to be able to render React components server-side inside of our infrastructure, inside of Python maybe. Can we, execute React inside of Python? Turns out no. We tried it, doesn't work. So I guess back to the drawing board. Reminder: this is what our stack looks like. We have our Python web server at the top there. A slightly more accurate description of what our Yelp ecosystem looks like would be this. So Yelp is actually multiple websites all glued together at the load balancer level. Different user flows might be grouped together, and their endpoints might be served by these different services. So for example, all of the pages related to booking things and reserving things on Yelp are served by the reservation pages service. So then the question is, well, we're going to need a node server to execute React components. We need something to call render to string. Now there's lots of great React server-side rendering frameworks out there. The one we ended up choosing is Hypernova from Airbnb. We chose this because it's pretty unopinionated and it does one thing pretty well, so it slots into our ecosystem. But we need to figure out where in this view we're going to deploy this node server. We have another fork in the road. Now we have two options here. The first is that we can spin up a dedicated service, so one instance of our node server somewhere, and we just have all of these other services send out network requests to our node server, and then it will respond with the React markup, put it inside of the template, and send it on to the user. The second option we have is this sidecar process option. So Yelp services are deployed inside of Docker containers. So we could just add in some process management, add in a node process that uses render to string, and then our Python server can communicate locally to this node server and deploy it that way, n times, for n different services. So some things to note here: if we go with this sidecar process option, then now we have multiple places in which this infrastructure exists. We have multiple things to maintain instead of just one. The other problem we have with this approach is that you can imagine as we're doing more work inside of this container, we're consuming more resources, more memory, more CPU, so we would need to grow the expected size of this container. This is a problem when it comes to deploying these containers. If we increase the size of the container across all of our different services, then deploying it becomes slower, finding available hosts to deploy these containers in becomes hard, so that's kind of messy. We don't want to get into that, so we ended up just going with option one. We have this one instance of a node server, and that's how we deploy Hypernova. So we figured out how to deploy it, but now how do we call it? So to make a request for a component, we might need all of these things. This is what a request might look like. So we need the service that the component is from. We need the name of the component itself. We need the version of the code that we want the component at. That could just be the Git shard. We also need what are the props to this component. So how do we get this data? So this is what an example render React component function call might look like from earlier. You can see here, okay, well we have the component name here as the first argument, we have the props here as the second argument, and then at runtime we magically know what the name of the service is, and we know what the version of the code we're at is. We save that information in a file somewhere. So that then allows us to build up this, this request, and we can go and request a fully namespace component in a namespaced bundle. So a brief note about Webpack. We use Webpack to build our client-side bundles along with Babel, Uglify, and other bits of tooling, and we think it's great. And we're about to need Webpack again. So when we have this render React component and this component name, well, where does this actually come from? How does Python know what this component called confirmation page, how does it know what this is and where it is in our JavaScript? So for every service, we have this special components entry point file. And in it, we import and then re-export all of the components that we might want to server-side render. We throw Webpack at this file, we generate a server bundle, we upload it to our node server, and so then we have this fully namespaced bundle. We do this for every service that we have, and that means that we have all of these different server bundles floating about inside of our node server so that when a request comes in from a service that says, hey, I need this component from this service, this version, our node server goes, yep, okay, that's this file over here. I'll import the component you want. I'll render it with the props. Here you go, here's your markup. So the final thing we need to work out is, let's say this is what the request flow for the Yelp request looks like. Where in this flow do we kick off the network request to our node server? So we have another fork in the road. Thank you. Now ideally, we would like to kick off the request as early as possible so that we can do the request in parallel and that we can sort of be efficient about this. But this doesn't quite work because ahead of time, we don't know what the components that we're going to want to render, we don't know what those are yet because we use this render React component call inside of Cheetah, and we haven't got to Cheetah yet. So without duplicating some logic, we don't know what components we're going to need. So we have to wait. The second option here is that we could, every time we see render React component, we could just kick off the request. But then this isn't so good either, because now we're doing network requests inside of template rendering, and that's not very pure. It's kind of slightly harder to debug. So the last option that we're left with is that we batch up all of these requests. So every time we see render React component, we kind of put a pin in that, and then we defer all of the requests until right at the very end. We make one request to Hypernova, we get the markup back, and then we go back and slot in the React markup where it should be inside of the template. So in a nutshell, that's how render React component works. So how will this impact performance? So we're kind of halfway to answering that question. The last bit of this question that we need to answer is, well, how does this affect performance in terms of numbers and figures? We need to make sure that this thing that we're adding on at the end doesn't slow down the whole request too much. We're pretty focused on optimizing and keeping our performance as quick as it can be. So we don't want to slow down the whole request too much. Worst case scenario, we slow it down and maybe the user gets bored and goes and clicks elsewhere. So that's no good, we don't want that. To give you an idea of the sort of existing budgets that we work with, this is a screenshot from Zipkin, which is a distributed tracing system. We run this internally, and this is showing here existing template rendering. This takes about 100 milliseconds on average. We would expect, as we do more React work and less Cheetah work, that this number would go down, but for now, yeah, we're just tacking on this React rendering work right at the very end, so we just need to make sure that it's as quick as possible. We gave ourselves at the beginning of this this SLA about 50 milliseconds. It's kind of within the same order. Before we went to production, we wanted to figure out, can we do this? So we spent a bunch of time doing some load testing on our internal infrastructure. It was important that we satisfied ourselves that before we ever deployed this, that this would be quick. On our internal infrastructure, our testing showed that given this target time of 50 millisecond round-trip time for React template rendering, we would probably get about 800 QPS. And we think that's a reasonable cost to performance ratio. The theoretical minimum was about half a millisecond, but 50 milliseconds for one core with 800 QPS, that's a pretty reasonable trade-off there. So how did we do? Did we achieve this? So this is a screenshot from our internal dashboards on production, and we're currently serving 50% of all React requests for the template rendering bit. We're doing that in about 3 milliseconds. Our P95 to 30 milliseconds. So yeah, we did pretty well there. Our load testing that we did before we went to production gave us that confidence, and we were able to make sure that these numbers weren't too crazy. So then, how will this impact performance? Yeah, I think we answered that one. So then, all that's left for me to say is how we're doing today. What does React at Yelp look like today? So we've converted over all of our style guide components to React. All new templates at Yelp are written in React, and React is running in some of our running in production in some of our heaviest trafficked routes. So I'll give a huge shout out to all the people who on our team and on other teams at Yelp who helped get this through in about a year. That was pretty cool. And then the last thing is that, so we use Hypernova, we also use Pyramid, so we ended up writing this client library to allow us to call Hypernova from inside of Pyramid. It's called Pyramid Hypernova. We just open sourced it today, so if you're also doing server-side rendering from the Python infrastructure, you should check it out. If any of what I've just talked about interests you, and you would also like to come work on some of these types of interesting problems, then we are hiring, so come speak to me afterwards. And if you'd also like to check out what we're doing elsewhere on the web, you can follow us on these links here. Thank you very much for listening. Are there any questions? We just have a few minutes. Yeah, so the question is, when we picked React, did we evaluate any other options first? So yes, we did. We sent out kind of internal questionnaires to our web developer community, and the responses that came back were consistent with like stateofjs.com kind of results. React came out to be the most popular. And something else which I didn't quite mention is that we had small bits of React running from individual feature teams. So there was already that initial momentum to do React at the company. Okay, cool. Well, thank you all very much for listening.